Today we're here with Dr. Eric Betzig from Howard Hughes Medical Institute and the 2014 Nobel Prize winner in chemistry. Dr. Betzig is one of our plenary speakers here at CLEO 2015 in San Jose, California. He will present on imaging life at high resolution. Optical microscopy has been the workhorse of dynamic studies of structure and function at the cellular level and below for more than 100 years. Where do you see the field going in the next 25 to 50 to 100?
Wow, that's a long time. For me, I'm lucky if I can have a crystal ball that can see 3 years ahead. But I know what biologists would like to have is basically they'd like to see the cell on its own terms. And photons are a good way of doing that because they're generally non-invasive, but they still present damage to the specimen. So everybody's always looking for ways of having, say, labels for cells that highlight certain proteins that require less light, or even getting rid of the labels altogether. If there's an optical phenomenon that we could develop that sees proteins directly, that would be a major advance. And cells have up to 10,000 proteins, types of proteins inside of them, yet we typically only look at them 2 or 3 at a time, so we're missing most of what's happening. If there were a way of seeing dozens at the same time, that would be another major advance beyond what we have today.
Would you share with us your quest to find the holy grails of optical microscopy?
So again, you just take it, think of myself as an engineer, so you just find where the low-hanging fruit is and start chipping away at it based on what both the laws of physics and current technology allows. So there was an opportunity that presented itself in 2005 when there was these photo switching molecules that came on the scene that made super resolution easy. And so we jumped onto that opportunistically. And then there was opportunities in new ways of crafting non-diffracting beams to do non-invasive 3D imaging of cells, and so that led to another one of our holy grails of trying to image long time without damaging the cell. And now we're trying to actually exploit what astronomers have done in adaptive optics so that we can deal with the heterogeneity of specimens and be able to see deep inside of living specimens still at high resolution.
You took several years off from science to work with your dad in Michigan. What perspective do you think that time away gave you, and where did it take your work today?
So I think it was valuable for 2 main reasons. One is to teach me humility, so that failure is a part of life, and that you're not always going to succeed, and you have to just pick yourself up again. But the other is listening to the customer, is that I feel like there's many people in optics, particularly in biomedical optics, in basic research, who do what they're doing because they can do it, not necessarily because they should do it, because there's a biologist who could use the tool that they're doing. And I think that more optics people need to become more informed of what the biologist actually needs to be able to help guide their research to something that's actually going to be valuable in the end.
Thank you, Dr. Betzig. We look forward to hearing more about your work later today at our plenary session. Thank you.